All right, let's get Unit 2 started off by talking about angle pairs. So it says use a diagram to list an example for each term below. So first of all, supplementary angles, angles that add up to 180 degrees, aka form a straight line. So we could say something like angle 1 and let's go angle 5. So those two angles would be supplementary, forming 180 degrees or a straight line. Complementary are two angles that add up to 90. So we could say angle 2 and angle 3 together form a 90-degree angle. Adjacent, that just means two angles that are side by side. So pick any two angles you want. Let's go angle 4 and angle 5. They're beside each other. Or angle 4 and angle 3. They're just beside each other. That's all it means. Two angles that are congruent, meaning they have the same measure. Well, we'll get into this here as the unit goes, but angle 1 and angle 5 they both look like they're 90 degrees. Angle 1 and angle 4 also both look like they're 90 degrees. And then a right angle. You could say angle 5 is a right angle, or angle 4, or angle 1. Any of those. So, adjacent angle. Let's start into a formal definition. So, adjacent angles would be, I'm going to have to pick a different color. So, two angles that share a common ray, aka a side. So in our example below, we have angle ABC. It's right here, ABC, and angle, now we can say CBD. CBD are adjacent angles. The reason is they share this side right here. It's two angles beside each other. They share that common ray, BC. So for each diagram below, we use angle relationships to calculate the value of each variable. So we have angle ABC and CBD. It looks like they are forming a straight line. A straight line is going to be 180 degrees. Those would be supplementary angles. So let's go ahead and add that note, supplementary. Okay, so that means is if I take this angle here, 2x plus 1, plus this angle here, 3x minus 31, together, if I add them up, they will equal 180 degrees because they are supplementary angles, which means they add up to 180. Okay, using the magic of algebra, we can combine some like terms. Whoops. So 2x and 3x is 5x. 1 minus 31 is going to be negative 30. Together, we'll get the 180. Add 30. Add 30. So 5x equals 210. Divide both sides by 5, and we are looking at, divide both sides by 5. 210 divided by. Okay. So the question you need to ask yourself now is that the final answer? Well, if you go back up to the question, it says calculate the value of each variable. Well, that didn't work. Calculate the value of each variable. The variable was x, therefore we have our answer, 42. Next problem. So now it looks like we have complementary angles, which means they add up to 90 degrees. So we can say that 2x, this angle here, plus 3x minus 10 equals 90 degrees. And again, combine like terms, so 5x minus 10 equals 90. Add 10 to both sides. 5x equals 100. Divide both sides by 5, and we will get 20. Again, solve for the variable, which we did. We are done. So again, using vocabulary to set these up, and then it's all algebra from there. So for each diagram below, use angle relationships to calculate the value of each variable. All right, so here's what we have. And we can look at these so many different ways, and we'll get into all the different ways here in just a little bit. But we have this angle here and this angle out here. What they're forming is a straight line, which means they are supplementary. So we'll use that setup again. Again, that means 180 degrees. You add them together, you get 180. So we're going to use that idea. So we're going to take 14x plus 4. Oops. 14x plus 4 plus 16x minus 4, and together we'll get 180 degrees. Combine like terms again. So that's the geometry part. Now it's all algebra. So combine like terms. 14x and 16x is going to be 30x. 4 minus 4 is, well, 0, so that's gone. Divide both sides by 30. X is going to equal 6. Okay, but it says to calculate the value of each variable. So we found 1. We know what x is equal to. So now we have to use that to find y. Well, I'm going to erase this quick. Here's what we have again. We have this angle here, and this angle again are forming a 180 degree. Oh, there we go. 180 degree angle. So we could set up an equation again. So I'll show you the setup and how it's going to work, and then we'll talk about what we're going to do. So 16x minus 4 plus 4y minus 8. Now the problem here is we have an x and we have a y. Right now with one equation we can't solve it, a single equation with two variables, but the nice thing is we know what x equals. We did that work right over here. So we can replace that x with a 6 and then simplify from there. Okay, so 16 times 6 is 96 minus 4 plus 4y minus 8 equals 180. So now we can combine like terms. So we have 96 minus 4 is 92 minus another 8. So 84 plus 4y equals 180. So all I did was just I multiplied 16 times 6, and then I just combined all my like terms, my constants. Subtract 84 from both sides. 4y equals 96. Divide 96 by 4. And y equals 24. So divide by 4, y equals 24. And again, it says solve for each variable, which we did. So we are done with the problem. All right, so now let's get into some theorems. So if angles 1 and 3 are both supplementary to angle 2, then angle 2 and angle 3, so if angle 1 and 3 are supplementary to, then angle 2 and angle 3 are congruent. So then you could say then, well, then is up there. Awesome. Then angle 2. No, if angle 1 and 3, yeah, then angle 2 is come on. Congruent to angle 3. So, yeah, so the congruent supplements theorem. So we're saying that angle 1 and angle 3, can't read, are supplementary to angle 2, meaning I can take, that's a terrible angle 2, so I can put angle 1 right here, and they form 180 degrees, or I can take angle 3 and put it there, and those also equal 180 degrees. That's what it's saying up here. That's what that supplementary means. So what that means is that angle 1 and angle, why does it keep disappearing? All right, I guess we won't do that. That means angle 1 and angle 3 have to be the same. Okay, so here we are continued. Let's talk about some specific types of angles. So a linear pair. This would be two adjacent angles, so they're side by side, that form a line. So a diagram would be, so here is, I don't know, we'll call that one angle, angle 1, and angle 2 out here. Hopefully you can see. I tried my best to show you that they form this straight line. So now we have vertical angles, which are two angles whose sides, there we go, whose sides form two pairs of opposite rays. So an example, the best example I can give you here is just two lines crossing. Vertical angles are opposite of each other. So 1 and 2 would be vertical angles, and here we go with 3 and 4. Those would also be vertical angles. They're formed basically when two lines intersect, opposite of each other. So let's think for a moment. What is the relationship between angles 1 and 3? Hint, it is vertical angles. It says it right here for you. That's pretty neat. But yes, we have two lines intersecting opposite of each other like this are vertical angles. What are the angle relationship between 3 and 4? Hint, it says it right here. It's a linear pair. Let's take a look here. So 3 and 4, here's 3, here's 4 right here. They form this straight line, meaning they're supplementary or a linear pair. So, taking a look at the linear pair postulate. If two angles form a linear pair, then they are supplementary. Which, like we've been talking about, linear pair means angles are forming a line. A line's 180 degrees. It means those two angles add up to 180, which means, it means that they are supplementary. So, last but not least, the vertical angles congruent theorem, which in its simplest form, normally we'd go through and prove this, but we are not doing that this year. In its simplest form, we can just say that vertical angles are congruent. For example, from the diagram on the right, we can say that angle 1 is congruent to angle 3. And we could also say that angle 2 is congruent to angle 4. And basically what that means is if If angle 1 is, let's say, 25 degrees, that means that angle 3 is also 25 degrees. Yeah, and that's it. They're congruent. They have the same degrees, same measure. All right, we'll do just one of these examples here. It says find the value of x and y. So again, similar to the angles we've talked about in the previous unit, you just have to kind of really know what these terms mean or what they look like, an example of what these look like. If you look at this diagram, it could be very difficult to figure out what you're even trying to do here. But we do know, hopefully, that this angle formed here and this angle formed here are vertical angles, which we just talked about are congruent, meaning they are the same, they are equal. So that's going to be our setup. We can say that 9x plus 7 equals 5x plus 67, okay, because they are vertical angles. So we'll go ahead and subtract 7 from both sides. 9x equals 5x plus 60. Subtract 5x. You could have done that in any order. It does not matter. So 4x equals 60. Divide both sides by 4. X equals 15. So it says find the value of x. So we're done with that. But we need that to help us find y. So to help us find y, we need to look at a different angle relationship. So I'm just going to go ahead and highlight this. It doesn't matter which way you go. I'm just going to choose the smaller numbers. But right here we have a straight line. Here we have one angle. Here we have another angle. Together they form a straight line. They are a linear pair. So what we can do is figure out how many degrees we have here by substituting x for that x right there. So let's take a look here. So 9 times 15 plus 7. So you get 135 plus 7. So adding those together here, I'll clear up a little bit of my marks. We get 142 degrees. We know right here is 142 degrees. Okay, so we know that again, this whole thing here forms 180 degrees. So we can say that 2y plus the 142 equals 180 degrees, because again, it's a straight line, it's a linear pair, they're supplementary, however you want to look at it. Okay, so we'll go ahead and subtract 142 from both sides. 2y equals 38. Divide both sides by 2, and now we have found y, which equals 19. And that is it.